Hi and welcome to the second part of a video series on LINQ. This video is also the second part of the 7th tutorial in an advanced C# course. LINQ stands for Language Integrated Query. In the first part of this video series, we looked at an overview of LINQ. We discussed that LINQ is the name for a set of technologies based on the integration of query capabilities directly into the C# language. I recommend that you view the first part of this video series on LINQ to gain a basic understanding of this technology. A link to the first part of this video series is available below in the description. Please consider subscribing for more content on advanced C# concepts like this and much more. And please ring the bell so that you'll be notified of future content released from this channel. In this video, we'll demonstrate examples where we'll create LINQ queries using method syntax and subsequently show how we can express the same LINQ query using query syntax. As discussed in the previous video, in this series, query syntax is recommended because the logic within the query syntax is easier to read. In this video, we'll look at code examples using the following LINQ operators: select, where, join, and GroupJoin. We'll discuss what is meant by method chaining and demonstrate an example that makes use of method chaining in the context of a LINQ query. We'll look at what is meant by deferred execution of LINQ queries and what is meant by immediate execution of LINQ queries. We'll discuss the inherent advantages of deferred execution in the context of LINQ. To further clarify our understanding of deferred execution, we'll create a code example where we'll implement deferred execution for our own custom extension method for an IEnumerable type. We'll demonstrate how the C# yield keyword is implemented in the relevant code example as part of code to implement deferred execution. At the end of the tutorial, we'll look at the join operator and the GroupJoin operator. We'll create code examples to help clarify our understanding of these two LINQ operators. In the first part of this video series, we discussed that extension methods and lambda expressions are fundamental to how LINQ works. We created our own extension method for filtering a generic list that can be strongly typed with any C# type, including user-defined types. We then demonstrated how a lambda expression can be created in calling client code, which enables the calling client code to determine how the relevant list of data must be filtered. The reason we created our own filter extension method was to help us understand the fundamentals of LINQ. LINQ functionality is encapsulated in two static classes that are members of the system.link namespace. These two static classes are named queryable and enumerable. These classes mostly contain extension methods As with the previous video in this series, I'm going to demonstrate the code examples in this video on my Mac platform. If you are using a Windows platform, the fact that I'm using Visual Studio for Mac should not be a barrier to follow along with these code examples. The code creation process is almost exactly the same experience when compared to implementing the same code using Visual Studio for Windows. So let's create a .NET Core console project. Let's name this project LINQ Examples _1. So to save time, let's copy data-related code that we created in the previous video of this series from the appropriate GitHub repository. So please navigate to this URL in your browser to access the relevant GitHub repository. As always, all URLs referred to in these videos can be accessed through appropriate links included below in the description. So let's copy the data-related functionality from this repository to the project we have just created. So in your browser window, click the directory icon labeled TCP data, like this. Click the class icon labeled employee. Let's copy the code for the employee class from this page to our clipboards like this, and simply paste the contents of the clipboard below the program class in our new project. Let's also copy the code for the department class like this to our clipboards, and paste the contents of our clipboards below the employee class within our new project. Let's then copy the code in the data class to our clipboards, then paste the contents of our clipboards below the department class in our new project like this. So we have some red squiggly lines within our data class. To fix this, let's include a directive to the system.collections.generic namespace at the top of our code, like this. We are just creating throwaway code in this video to help us understand the relevant topics discussed in this video. So we are not too concerned with code neatness in this video. In our main method, let's create a strongly typed generic list that is strongly typed with the employee user-defined type. Let's name our generic list variable employee list. Let's assign the value returned from the data.getEmployees method to the variable we have just named employee list. This line of code will populate the employee list collection with made-up data that was hard-coded in the data class in the previous video of this series. Let's define a generic list that is strongly typed with our department user-defined type. Let's name our variable for this list department list. Let's assign the value returned from the data.getDepartments method to the variable we have just named department list. This will populate the department list collection with made-up data that was hard-coded in the data class in the previous video of this series. So let's create a LINQ query that makes use of the select LINQ operator. In order to use a LINQ operator, we of course need to include a using directive to the system.link namespace. For this query, we want to select everything from the data stored in our employee list collection. We can do this by simply invoking the select method on the employee list object, like this. The select method is an extension method provided to us through LINQ. We can shape our data through the use of a lambda expression like this. We discussed anonymous types in the previous video of this video series. So, the select operator returns an IEnumerable collection of objects. The lambda expression passed into the select extension method provides an instruction on how we wish to shape each item of data within the returned IEnumerable collection. This is specifically expressed through this anonymous type. Anonymous types provide a convenient way to encapsulate a set of read-only properties into a single object without having to explicitly define a type first. You can see how the use of anonymous types can provide the developer with flexibility and convenience when constructing queries. So here we are providing an instruction that we want each item of data in the returned IEnumerable collection to contain a full name property, which is a concatenation of the first name and the last name properties of the relevant employee record, and a property containing the employee's annual salary. So let's write the code to output the results of this query to the console screen. Let's see the code in action. Great! So if we want to filter this data, we can do this by chaining the where extension method to our select operator like this. Method chaining is a common syntax for invoking multiple method calls in C#. Each method returns an object, allowing calls to be chained together in a single statement without requiring variables to store the intermediate results. So the select operation will return an IEnumerable collection object. We can filter this returned IEnumerable collection within the same LINQ query by chaining the where extension method to the select extension method. The where extension method filters the data stored in the IEnumerable object returned from the select method through a lambda expression passed to the where extension method. The lambda expression provides instructions to the where extension method on how the data must be filtered. Once the data has been filtered through the where extension method, an IEnumerable collection of results is assigned to our results variable. We are then traversing our results using a for each loop and displaying each item in the IEnumerable collection to the console screen. We discussed the var keyword, which allows for local implicit typing within methods in the previous video of this series. Please view the previous video in this series for more details. So here we are implementing LINQ explicitly using the extension methods provided by LINQ. We are using the select operator and the where operator in a LINQ query implemented using method syntax. Let's run the code. Great! We can execute the same functionality using query syntax. So let's comment out the previous code and include a comment to label this code so that we are able to refer to this code later if need be. So let's first implement the LINQ query using query syntax without the where clause. Let's run the code. Great! Let's implement the LINQ query implemented using query syntax, and this time include the where clause within the LINQ query using query syntax. Let's run the code. Excellent. And we get exactly the same result when compared to running the query that we implemented using method syntax. But we have constructed our LINQ code using LINQ query syntax as opposed to using relevant extension methods. The query syntax is more readable, and we don't need to chain our extension methods, as we did in the previous example where we changed the where extension method to the select extension method. Let's take a closer look at our query where we used method syntax versus the same query where we used query syntax. Note that standard query operators in our query syntax are converted into extension methods at compile time. So standard query operators are essentially the same as their counterpart extension methods. Microsoft recommends using query syntax as opposed to directly implementing the relevant extension methods where possible. As discussed, this is due to the readability advantage inherent in the query syntax. There are times when you will need to use extension methods directly where equivalent query syntax is not available. We looked at a few examples of this in the previous video of this series. For example, using aggregate functionality, like for example finding the average, min, or max annual salary for a collection of employee records. We would need to use the respective average, min, or max extension methods to calculate and return the relevant values. The developer is able to execute LINQ queries with deferred execution or immediate execution. So let's first understand what is meant by deferred execution. Deferred execution means that the evaluation of an expression is delayed until its value is required. This improves performance because only necessary executions are carried out, i.e. at the point where the relevant value is required. Let's use our last query example to illustrate this point. So when we first assign the value returned by our query to our results variable, the query is not executed. It is only when we traverse the items in our results variable that the actual execution takes place, i.e., with each iteration of the for each loop, an execution is performed, whereby the relevant item is evaluated and returned from the collection. Another advantage of deferred execution is that an update to the relevant data collection will immediately be reflected in the results. So, for example, let's add a record to our employee collection. Note, the salary for this new employee is above 50,000, so this employee should appear within our results. Let's run the code. And you can see that this is proof that the results are evaluated within the for each loop, and the query itself is not executed at the line of code where the relevant query is located. The execution of the query is deferred until the results are traversed within the relevant for each loop. To further understand the concept of deferred execution, let's create a code example where we'll implement deferred execution for our own custom extension method for an IEnumerable type that is strongly typed as the employee user-defined type. Let's create a static class named Enumerable Collection Extension Methods. Let's create a static method within the static class that we have just created, and let's name this method getHighSalariedEmployees. We discussed extension methods in the previous video for this video series. For more information on extension methods, please access a link to this video. As discussed, a link to this video is available below in the description. So let's implement the code for the getHighSalariedEmployees extension method, like this. Note the use of the yield keyword. You can use a yield return statement to return each element one at a time. The sequence returned from an iterator method can be consumed by using a for each statement or LINQ query. Each iteration of the for each loop calls the iterator method. When a yield return statement is reached in the iterator method, the relevant value in the IEnumerable collection is returned, and the current location in code is retained. Execution is restarted from that location the next time that the iterator function is called. Let's go to our main method and implement a query that calls our extension method on the employee list collection. Let's copy and paste the code that we have already written to traverse the results and output the relevant data. And let's add another employee record to the employee list collection as we did before. Let's run the code. And you can see that the new employee record is reflected in the results. The results are kept up to date due to deferred execution. Note that deferred execution reevaluates on each execution, which is known as lazy evaluation. The converse of deferred execution is immediate execution. Immediate execution means the relevant query is executed immediately. To execute a query immediately, we need to apply an appropriate toConversion method to the query. So let's copy the previous code example. Let's uncomment the relevant code. Let's change this code so that the query executes immediately. We can use the toListConversion method for this purpose. We are using query syntax here, so in order for us to use the toListConversion method, we first need to wrap the relevant query in brackets, add a dot, and then the toListConversion method. We are explicitly typecasting the IEnumerable value returned from the query to the list type through the implementation of the toListConversion method. We are also executing the query immediately. Let's uncomment the rest of the relevant code for this example. And let's run the code. You can see that the execution of our query is immediate, because this time, after we've added a new employee, the query has not been evaluated again to include the new employee record in the results. This is, of course, why the new employee does not appear within the results output to the screen. This proves that our query has executed immediately at the line of code where the query is located. And remember that query syntax does not support toOperators, so we need to wrap our query in brackets, as we have done here, and call whichever to method is appropriate, for example, toList, toArray, or toDictionary. By calling the relevant to method, in this case the toList method, we are causing our query to execute immediately. Without the toConversion method, the relevant query execution would be deferred until the relevant results are iterated. So let's move on to the join operator, and then we'll look at the GroupJoin operator and highlight the difference between these two join operations. In the previous video in this series, we looked at the join operator and discussed how we can perform an inner join on two IEnumerable collections using a LINQ query. So here we have two collections that we wish to join. In this specific use case, we need to include a descriptive department name in our results displayed to the user. We only have a department ID field in our employee type, so in order to merge the properties from our employee type with the relevant property from our department type, we need to join records of type department that reside within our department list collection with records of type employee that reside within our employee list collection. We can do this by matching the ID field in the department records that reside in the department list collection with the department ID property of employee records that reside in the employee list collection. We can do this through LINQ by using the join operator. Later, we'll demonstrate a join operation, but using the GroupJoin operator. We'll also discuss the differences between the join operator and the GroupJoin operator. Let's look at the relationship between the collection of department records with the collection of employee records. Department records have a one-to-many relationship with employee records. A specific department can have many employees as members. A specific employee cannot belong to more than one department at a point in time. Data collections can also have one-to-one relationships with one another, or many-to-many relationships with one another. So in this example, we are going to look at how we can use LINQ to implement a join operation between two collections of records that have a one-to-many relationship with one another, i.e., one department to many employees. So let's implement a query that joins the department list collection with the employee list collection, where the ID property of the relevant objects of type department match the department ID property of the relevant objects of type employee. So the syntax for this LINQ query would look like this, when we implement the join operation using method syntax. So to join department records to appropriate employee records, we can use the join extension method and invoke the extension method on the department list collection. The first argument we need to pass into the join method is the collection on which we want to join the department list collection. So we pass in the employee collection object here. The second argument is the key from the outer collection, the department list collection. So the outer join key is the ID property that resides in the department type. We can express this argument as a lambda expression like this. The third argument is the inner join key, which is the department ID property which is a member of the employee type. We can express this argument as a lambda expression like this. So we are joining on the ID property which is a member of the department type with the department ID property which is a member of the employee type. We can define an anonymous type where we are able to shape the data for each item in an IEnumerable collection that we want returned from the relevant query. Here we are defining an anonymous type within our LINQ query that includes the employee full name, which is a concatenation of the employee's first name and last name, the employee's annual salary, as well as the relevant department object's long name property. The long name property will give us a descriptive department name in our results. We are including the department type's long name property in the relevant anonymous type. This is the whole point of joining the department list collection with the employee collection, so that we are able to include a descriptive department name within our results. We only have the department ID as a member of our employee type, so if we only returned results from the employee list and wanted to include department information, we would be restricted to the department ID property, which is an integer value and is unlikely to be meaningful to a user. Let's run the code. Great! But as discussed, where it is possible to use query syntax rather than method syntax for our LINQ queries, we should use query syntax because the logic expressed in the relevant query is far easier to read. So let's write the same query using query syntax. As you can see, it is far easier to read, and it is also similar to query languages with which we may already be familiar, for example, Transact SQL. Let's express what a similar query in Transact SQL might look like. So let's imagine that we have a table in a SQL Server database that could map to our employee type. Let's say this table has the same name as our employee type. Let's also imagine that we have a table in the same SQL Server database that contains a table schema that could map to our department type. Let's say this table has the same name as our department type. So the Transact SQL would look something like this. You can see how the from clause, the join clause, and the select clause are implemented in both the LINQ query syntax and the Transact SQL syntax. Even though the LINQ query contains the same clauses in a different order to the comparative clauses in the Transact SQL query, for someone who is familiar with Transact SQL and not necessarily familiar with LINQ query syntax, this LINQ query syntax at a glance should be fairly easy to understand. So the point here is that LINQ query syntax is similar to query syntax with which many of us will already be familiar. So this makes the implementation of LINQ queries using query syntax more intuitive. As discussed, the LINQ query syntax is also more readable than the equivalent LINQ query implemented using method syntax. So the key takeaway here is to use LINQ query syntax rather than method syntax where possible, because it is more intuitive to implement and easier to read. Let's run the code. Great. So let's look at the GroupJoin LINQ operator and why we might want to use the GroupJoin operator in our LINQ queries. We have just performed an inner join using the join operator. This query will only return those records based on the ID property of relevant objects of the department type in the department list collection, matching with the department ID property of relevant objects of the employee type in the employee list collection. Diagrammatically, an inner join query can be represented like this. What if we wanted to return, through a LINQ query, all the department records in our department list collection and only employee records where the department ID property of employee objects in the employee list collection match the ID property of department records in the department list collection? So if we were to write the Transact SQL version of this query, it would look something like this. We would use a left outer join to achieve the desired result. This query would bring back all department records, but only those employee records where the relevant employee records department ID values match the ID property of the relevant department records. So, diagrammatically, we can represent a left outer join query like this. So let's look at the diagram representing an inner join operation and compare the diagram to the diagram representing the left outer join operation. So let's use our GroupJoin operator in a LINQ query to return all department records from the department list collection, but only the employee records from the employee list collection with a department ID property that matches an ID property of a department record in the department list collection. So here we are implementing our query using method syntax. You can see the implementation of the GroupJoin operation using method syntax is very similar to the way we implemented the join operation in the previous example. Let's run the code. Note, the way we have structured our output is clearly different when outputting the results of our GroupJoin query when compared to the way we structured our output of the results of our join query. But note that at the moment the same join between department records and employee records has occurred. The reason for this is not because the GroupJoin and the join operators perform the same type of join operation. It is because currently each of the records in the employee list collection match with a department record in our department list collection. Let's change our data to highlight a key difference in the join operation and the GroupJoin operation. Let's do this by going to the code where we have hard-coded, made-up employee and department records and added these records to their respective collections. Let's ensure that the technology department, which has an ID of 3, does not match with a department ID property of any of the employee objects in our employee list collection. We only currently have one employee that is in the technology department according to our data. Let's change the relevant department ID so that there are no employees that are members of the technology department. So let's change this department ID property. Now, no employees are members of the technology department according to our data. Let's run the code. So you can see our technology department record is being returned along with all the other department records in the department list collection, even though its ID property doesn't match the department ID property of any employee records stored in the employee list collection. So, simply put, department information for departments that contain employees are included in the query results, and departments that don't contain any employees are also included in the query results. In this example, the technology department is returned even though it contains no matching employee records. So here we have performed a left-outer join query using LINQ's GroupJoin operator. So let's rewrite this LINQ query using query syntax. You can see here that the GroupJoin extension method does not get explicitly called when we implement our query using query syntax. The into keyword is used within the query to create a group of employees for each department. So as discussed, LINQ query syntax does not match exactly when comparing LINQ query syntax to familiar query languages like Transact SQL. But in many ways, it does resemble a language like Transact SQL. In this sense, LINQ query syntax is more intuitive to implement than method syntax when implementing LINQ queries. And just to labor the point, as discussed, it is also better to implement LINQ query syntax for our LINQ queries than implementing method syntax for the same purpose because of better readability. Let's run the code. Great! And we get the exact same result as when we ran the same query that was implemented using method syntax. Now that we have changed the data so that the technology department does not match with any employee records, let's run our join operation that we created earlier. Notice that the results of the join operation doesn't include the technology department. This is because the join operation performs an inner join, and with the group join operation, we are able to perform a left outer join operation. So let's comment out our join query and uncomment our group join query. And for good measure, let's run the code again. And as you can see, the technology department is now included in the results displayed to the screen, even though the technology department does not have any matching employee records. Great! So the left outer join operation returns all records from the outer left collection in the query, but does not return records from the inner collection, where the inner collection records do not match any of the outer collection records. So if there were employee records in the employee list collection that did not match any of the department records in the department list collection, these employees would not appear in the results outputted to the screen. We can prove this. Let's change the department ID of this employee record where the first name property is Bob and the last name property is Jones. We have changed the department ID property for this record to 6, and there is no matching department record, i.e. no department record has an ID of 6. Let's run the code. And you can see that the employee record with first name Bob and last name Jones does not appear within the results. However, even though the Human Resources Department has no matching employee records, it is still included in the results outputted to the screen. Great! Let's add Bob Jones back into the Human Resources Department like this. And let's run the code. Excellent! So hopefully this made it clear how we are able, through LINQ, to use the join operator to perform inner join queries between two object collections, and how we are also able to perform left-outer join queries using the GroupJoin operator. I hope you have enjoyed the second part of this video series on using LINQ within our C# applications. In the next video, we'll look at more LINQ query operators that we can use in our LINQ queries. Please consider subscribing for more content on advanced C# concepts and much more. And please ring the bell so that you'll be notified of future content released from this channel. If you feel you have gained value from this video, please hit the like button. It will be greatly appreciated. Please feel free to share any of my videos with anyone you feel may benefit from their content. I really enjoy reading your comments, so please feel free to share your thoughts with me in the comments section. The code created for this video is available on GitHub. A link to the relevant GitHub repository is available below in the description. A special thanks to those who have recently subscribed. I'm happy to say the growth of this channel seems to be gaining momentum thanks to you. I would of course also like to thank all those who have subscribed. Your support is greatly appreciated. Thank you and take care.